everyone, my name's Con Grilakis and I'm the CEO of Flavourtech. What I'd like to do in this webinar is take you through both a bit of information about our company and also how the IS can help you achieve more with your RTD tea or coffee. We'll explain the IS to you, and then also we'll explain to you how modifying the parameters and the operating conditions of the IS systems will enable you to achieve more with your product and customize your products for your markets. But first of all, a little bit about Flavourtech. Flavourtech is actually based in Griffith, which is in New South Wales, probably equidistant between Melbourne and Sydney by about 6 hours by car either way. And the reason why we're based in Griffith is because we're actually one of the whole Murrumbidgee irrigation area, is actually one of the largest food producing regions in Australia. And that's where we began as a company back in the wine industry about 30 years ago. And we are based in this region. And when I say based, we actually do everything. We manufacture, we build our systems, we build our control systems. All of our operations are actually based in this town. You'll see that on the photo at the moment, there's a picture of our warehouse, and you can see our hive of activity that's taking place. And all of our functions are actually centered around this location, although we do have a number of offices for sales and marketing, service and support across the world. A little bit about our philosophy, and you'll see our mission statement covers a number of areas. The first thing that we'd like to acknowledge is obviously we're an Australian company. We're focused on the food and beverage industry, but what we really value is our innovative engineering expertise, but also our people's and our staff's application expertise that helps our customers achieve more by combining both our technology with our knowledge. Our focus is on thin film technologies, and that allows the processing of material using much shorter residence times than before, and also lower operating temperatures. By doing that, we're able to produce products that have a much higher level of quality in terms of less damage, much fresher, much better aromas, and also we allow customers much higher level of control and automation as well. We'd like to think of it as though our spinning cone technologies really allow us to bring the natural goodness and capture the natural goodness of products in a natural way by using steam and not any chemicals or solvents. And I guess that is the essential premise of how we view our business. Our goal is to help our customers to succeed. And in terms of where we are as an organization, certainly we have business in Australia, but that's only about 10% of our business. Most of our sales actually take place across the whole world. You'll see on this map where we have our business distributed by the different continents, and really you'll see a very broad distribution across Europe, Asia, the US, North and South. You'll also see some stars on the map, and that's where we have offices. So for example, in London, in Reading, just outside London, we have an office there with Phil Riley and another 5 staff where we offer sales, service, support, and even trials. We have a full pilot plant facility set up at the University of Reading in the UK. And so on across the different regions. We have strong distributors in the US, Scan American, and we also have staff directly in Central America and in India. And for that reason, we do actually act globally as well. So as well as all of our marketing, and you'll see on this next slide some of the brochures that we have, translated into many different languages. There's Spanish, Korean, Chinese, Japanese, and everything we do has a very global perspective in its nature, because we really are a global company, and 90% of our sales are occurring across the world. And in addition to providing our brochures and sales and marketing and operating systems in different languages, we also have a very strong focus on supporting local seminars and workshops across these countries. You'll see on this page that we have Phil Riley giving a lecture at a recent Flavour and Fragrance Summit that was held in Shanghai. It was actually April of last year. And Phil was actually the keynote speaker who spoke about flavours, of course, and how you can extract more using our technologies. In addition to that, the chairman was Adam Ling, and you'll see him behind the blue background there on the bottom part of the page, who is our sales manager for that region, for China. He was also the chairman for the whole conference because he can speak Mandarin as well as English. And also Leon Skaliotis, who you might pick out in those other sort of the other pictures in the middle down the bottom there, in the center of that montage there. And Leon, of course, is our sales and marketing manager who also attends these meetings. So you can see we have a very strong focus at all of these seminars. In terms of what industries and what business we focus on, certainly coffee and tea is one, but dairy, alcoholic beverages, where we originally began, are also very important for us. We have some large global dairy companies that are using our spinning cone technology. Flavor houses across the world use the spinning cone column. Fruits and vegetables manufacturers are using either the spinning cone column to extract flavors, or the Centritherm to evaporate their products. And more recently, we've seen a lot of success in the pharmaceuticals and nutraceuticals industry as well. But I guess it'd be fair to say, in summary, coffee and tea probably is the #1 industry we're in. Certainly, it's about half of our business. And I think it'd be a fair comment to make that across the world, I think we are now becoming respected as a leader in the development of premium coffee and tea extracts, powders and flavors in the coffee and tea space. So that's a little bit about our business and our company. And now I would like to hand over to Leon Skaliotis, who's our Sales and Marketing Director, who will give a bit more information about the IS, or the Integrated Extraction System, and how that works.
Thank you very much, Con, and hello everyone. As Con has mentioned, I will be talking about the integrated extraction system, and particularly explaining the different parts of the IES system and how it operates and what we find around the world. So let's get started. If I was to actually say what the IES system is in as short a sentence as possible, I would say that it's an integrated and continuous system for the production of premium quality flavors and concentrates, particularly for the RTD industry. But more than that, I would like to say that it's a concept. It's a concept about how to make the best flavors possible and the best concentrates possible. The system, as you see it there in that photograph, doesn't have to be purchased in its entirety. Sections of it can be installed or implemented in any factory, in any existing process to improve that process. So it's a concept that Flavourtech developed when customers approached Flavourtech and said, well, help us with our business. At that time, most customers were conducting a batch process. And as you can understand, the batch process has its limitations, but also it has various challenges. And most of our customers were facing these challenges, which included a very labor-intensive system. You know, they had people running around everywhere, emptying tea bags or coffee, mixing it with water, then drawing a valve here, filling a tank there. And the batch process is also very, has a very high requirement for space, you know, depending on the volumes that you want to process. Another problem that they were facing was the fact that there was inconsistent brewing of tea depending on the operator that was running the batch process at the time. You know, a difference in 5 minutes, from 5 minutes of brewing to 10 minutes of brewing, if you know something had happened, would create heavy stewed notes in the final product. So, you know, your final mixed product would have different flavors and inconsistent flavors. Another issue or another challenge they were facing was the fact that because they were using a batch process and typically open batch tanks, a lot of the light, fresh notes that make tea so desirable, and a lot of those freshly brewed, roast and ground notes from coffee were being lost into the atmosphere and not ending up in the final product. And lastly, batch processes can be very inefficient, and I have to say that in my travels I've seen people conducting batch processes and brewing tea from anywhere from 5 minutes to half an hour, trying to extract as many of the soluble solids as possible. And I'd like to say that the IES meets all these challenges head on and produces a very high quality product. So in meeting and in trying to find a solution for customers, Flavourtech came to the party with a lot of knowledge and expertise already on hand. We had been working with flavour companies for the last 30 years, and in that time had determined that the best flavours actually came from processing a slurry. And when I mention the word slurry, I mean tea leaves mixed with water or ground coffee beans mixed with water to create a slurry mixture. And by processing the raw material, we could actually achieve much better flavours. And we do that in the flavour industry all the time with various fruits, with various vegetables, to produce the very best flavours possible. The spinning cone column was found to be an ideal unit to recover the desirable aromas, and both myself and Phil will talk a little bit more about that. But we also found that it was ideal for performing the soluble solid extraction at the same time. So it's a double barrel effect, capture the desirable aromas, but also perform the extraction of your tea or coffee at the same time. So it really provides some excellent advantages to the processing within the factory. So why did we decide to go into the IES and the RTD market? Well, you know, just some background information, which you're probably all very well aware of. We're finding that consumers around the world are slowly moving away from fizzy drinks. They're looking for much healthier products. They're moving away from some energy drinks. They're moving away from juices. A lot of people now with lunch grab a bottle of water or a bottle of iced tea. If you're on a long drive, instead of getting an energy drink, you might look at getting a canned coffee just to give you that pep and, you know, without having to wait for a coffee to brew. We're also finding that in very many of the developing economies like China and India, the middle class is actually growing. And this is, again, triggering a growth for the RTD market as more and more of those people move into work environments where they have to grab a quick lunch. An RTD tea or coffee, you know, meets the criteria of grabbing something and moving along. We're also finding that many companies around the world are targeting the younger market. You know, China, for example, young people there don't want to wait to brew a pot of tea anymore. They want that flavour, but they want it now, and they want to pick it up from the fridge of their local store. So it's a way of attracting younger consumers, whether it be to an existing product like tea or trying to give them a new experience, you know, trying to produce an RTD coffee product for the Chinese market, which is typically a tea drinking country. And the same can be said for India. And this is all, of course, validated by the fact that research companies like Markets and Markets, and just let me go back there for a second, Markets and Markets are saying that the forecast for growth of ready-to-drink coffee and tea is 5.5% and 13% respectively in terms of category growth every year for the next 4 years. And we're seeing that globally as we travel around the world talking to customers. So over the years, Flavourtech has built a heap of experience from other industries which we can implement into the RTD industry for production of premium flavours and concentrates. To provide you a little bit of a picture of what we see, this is a photograph from a 7-Eleven in one of the Asian countries, and those top 4 rows in that fridge section of this 7-Eleven are all ready-to-drink coffees. In this particular country, there's almost 10 different companies vying for that market of ready-to-drink coffee. And in fact, if you have a look at the bottom row, that's the only row that has juices. Top 4 rows, all different coffees, whether it be in aluminium bottles or in cold cups, so it looks like you actually have just purchased a takeaway coffee, but it's a nice coffee inside. So, different types of packaging to appeal to that younger market. In countries like Japan, of course, which is an interesting market. Japan, for those of you that aren't aware, is the 4th largest importer of coffee beans in the world. 20% of that imported coffee is actually consumed as canned or ready-to-drink coffee. And one of the ways of distributing that by many of the beverage companies in Japan is through vending machines, of which there are something like 5 million vending machines throughout Japan. You will find them under stairwells, in offices, at train stations, even down the street as you go along for your walk. And one of the ways they can attract customers is the fact that, if it's a cold winter day and you want a warm coffee, you press a button for a warm coffee to come out, or a warm tea. If it's a summer day, likewise, you can get a cold drink out. So a real enjoyable way to get the coffee or tea that you want pretty much wherever you want. So let's move on and explain more about the IES and the various modules that exist. The IES can be seen as 4 separate modules. The first one is the slurry processing module, where your tea or coffee comes in, gets mixed with water to create the slurry, which then goes into module 2, which is the spinning cone column. Now here, the slurry, it has the aroma removed, and you can vary the conditions of operation, so you can remove the aroma that is preferable to you and your market. But at the same time, the coffee or tea is brewed. The de-aromatized slurry then goes to module 3, which is the clarification module. And I'll explain this a little bit more shortly. But there, the solids from the slurry and the extract are separated. And that extract can be then concentrated at the Centritherm evaporator, or the evaporation stage. So you end up with 2 very distinct products, a high quality aroma and also a high quality concentrate. But as this is a concept, if you had this line in your factory and right next door had your bottling line, obviously you wouldn't have to concentrate. So you could remove that evaporation step and have the extract, once it's clarified, going straight to a blending tank and then straight into bottling. So each of these stages can be inserted in existing processes or even started off slowly, and then the whole process can grow as the needs grow. So let's look at the individual modules. The first one is the slurry processing module, where your tea or coffee comes in. It is loaded onto the hopper, and using a metering screw or auger, the tea or coffee beans are moved along into the mill. Now, as you can see, we're actually adding water into the mill. So Flavourtech developed a wet milling system. Now, as you can imagine, you're cutting something, whether it be fruit, vegetables, tea, you can smell that product, which means that you're losing many of those light volatiles that are important for freshness into the atmosphere. So by applying water during the milling stage, we're blanketing the cutting process and the product, and ensuring that all those light volatiles are kept in the slurry. The cut product then goes into a mixing tank, where more water is added to create a consistent and uniform slurry, because this is very important in the next stage, where you are recovering aroma and also conducting the extraction. If you have a varying slurry rate going into the SEC system, it will change or make it harder to have consistent aroma and consistent extract. So this slurry processing module being automated ensures that you get the very best from the rest of the system. So if you have a look at the slurry material itself, and Phil in his presentation will explain a little bit more about what sizes we cut down to. This photograph is green tea slurry, 10% slurry ratio. And you can see it's quite a thick, viscous product that has exited the spinning cone column. And of course, because we're dealing with pumpable materials, we have some maximum slurry ratios. For tea, it's less than 12%, and for coffee it's less than 20%. And it really has to do with the absorption qualities of the product. Module 2 is the spinning cone column, and this is really the workhorse of the whole system. The spinning cone column is a steam stripping distillation column that is used in many industries for the recovery of high quality aroma. A photograph of the spinning cone column is shown there on the left hand side of your screen, and within that column there we have a rotating shaft, and attached to that rotating shaft we have spinning cones, and attached to the walls we have cones that are not spinning, stationary cones. So the product comes into the spinning cone from the top, falls on the stationary cone, shown in red here, runs down under gravity, falls onto the spinning cone, and then the centrifugal force sends it up, it hits the wall, falls down on the next stationary cone, and continues on down the column. From the bottom of the column, we have the steam vapor, shown in blue, going in the opposite direction. And as those two phases mix, the volatiles are picked up, taken out of the top of the column and into a condenser where they are condensed into a clear liquid. On the underside of the spinning cones, we also have these fins that create almost a cyclone effect to ensure that those volatiles are taken out of the spinning cone column as they're being produced. The spinning cone column benefits are many. Just to touch on the few, well, that whole process inside the column only takes 25 seconds. So both preferable aroma recovery and brewing happens at the same time within 25 seconds. And because we can change various operating parameters that Phil will mention shortly, you can control what aroma compounds that you actually capture from the system. So you can create many different aroma profiles from the same raw material. What this means is that coffee products, single origin coffee, well, if you want to capture that quintessential essence of that single origin coffee, you can. If you want to capture the essence of single estate teas that make them so distinctive, you can. It's not the same tea aroma that comes out. In fact, even from the single coffee or tea, you can capture various aromas. And a little anecdote is we once had one of the presidents of a coffee company tell us that prior to the spinning cone column, they would run 200 different coffee blends and end up pretty much with the same coffee aroma. However, since they purchased the spinning cone column, they can run one coffee blend and produce almost 200 different aromas, depending on how they operate the system. Other benefits of the spinning cone column include that it's very easy to operate and very flexible. Previously, many processors or contractors would approach their customers and say, here's my tea aroma, and do you like it? And of course the answer would be yes or no. However, now, since it's so easy to tailor various aromas, you can approach your customers with 10, 15 different aromas made from the same raw material and say, which aroma do you like? And of course, if there's something in between the two aromas that you've already made, you know that you can tailor that aroma to suit the requirements of that customer. And this is pretty much how most of our customers grow, by being able to easily and flexibly tailor the products to meet their market requirements. For powder manufacturers, if you're taking that aroma and concentrate it and taking it to a spray dryer, there are also other advantages with the spinning cone column aroma in that it's concentrated. So the dilution effect to your concentrate prior to the spray dryer is much less, meaning that you can either save energy at your spray dryer or increase the capacity of your spray dryer. Of course, the spinning cone column is very simple, continuous, easy to use. There's reproducible results. The operator is taken out of it. Low energy requirements. It also has built-in clean-in-place functionality and low labor requirement. So that's the spinning cone column. The next step, of course, is the clarification module. So the slurry from the spinning cone column, after it's been brewed, goes first of all into a decanter where the bulk solids are removed, and then into a centrifuge to remove the cream and fines. Now, depending on the clarity that you want to achieve, and Phil will touch on this during his presentation, you can also add to this a separate filtration step to achieve a really high clarity product. So if you're bottling in a PET bottle, clear PET bottle, you may want to go for the polishing of the extract. If you're packaging in the can, you could probably stop at the clarifying centrifuge. The last step, if you are going to concentrate your product for logistics reasons, because bottling may be in another country, is of course the Centritherm evaporator, which, as Con mentioned, is another technology that uses centrifugal spinning cones to create a very small film thickness of less than 1 millimeter, which means that we can operate this evaporator typically at 50 degrees Celsius or less, and the heat contact time with the product is only 1 second. So we have very high quality concentrates that are manufactured on this, and it's one of the reasons why it's gaining popularity in the pharmaceutical industry, because active ingredients are not damaged. Enzymes, proteins, polyphenols are not damaged, and the color is also not damaged. Because of the centrifugal properties, we can also achieve very high concentrations and viscosities. And if you have a look at the photograph down in the bottom corner, that is coffee concentrate coming out of the Centritherm evaporator at 70% solids. However, typically we find that most customers concentrate to less than 60% solids for both tea and coffee. Again, the system is fully automated, has built-in CIP, so it is integrated into the IES, so it talks with all the other modules as well. So the IES is really Flavourtech's concept of a high-quality approach to RTD tea and coffee production, where your tea and coffee goes into the mill. We develop the wet milling process to capture the very best of the volatiles. The brewing and the aroma recovery is very easy and flexible, and happens in 25 seconds to produce a high-quality aroma. And then once the clarification step happens, you can also produce a high-quality concentrate. And these can be shipped separately for blending at the bottling line, or they can be blended and then shipped for bottling at particular locations if you want to control the blending itself. So the benefits in the IES process, if I was to break it down into 4 concise steps, well, it's modular, it's continuous, it's automatic. The modules can be added slowly to an existing facility, and it really produces a high quality product with a desirable and preferred aroma profile and a consistent end product. And as you'll see shortly, it's a very compact system. So let's have a look at the 2 sizes that we manufacture. And prior to going into that, let's see the design of the systems. We can either build it in a straight line, and in this factory you actually see 2 IES systems side by side, and this is a factory in America where space is not such an issue. However, in countries like Japan, we can condense the footprint even further, and this photograph is taken at a IES facility in Japan that was built on the 4th floor of the building, where the coffee beans are actually coming from the 5th floor, all the liquids are going down to the 3rd floor, bottling is on the 2nd floor, and it's a very, very small footprint. So we can accommodate any customer, any space requirement, and of course all these systems have can be operated at a lower feed volume, so you can start off slowly, and as your business grows, meet the higher capacity demands that you will most likely meet. The 2 systems, the IES 25 is our smaller system and uses the SEC 1000, which only has a footprint of 2 meters by 2 meters for the processing and the brewing and the aroma recovery. And I won't go through these particular values, but we'll let you know that you can log back onto the webinar once we're finished to obtain these values. All I will say is that these values are both for tea and coffee, both raw material use per day, aroma production per day, and concentrate production per day at 45 bricks. And there's some assumptions that we've made there for you to also consider the operation of. So the IES 25 is our smaller system. Our larger system is the IES 250, which uses our larger SEC 10,000 column, and our larger Centritherm CT12 evaporator. And you can see there the use of tea leaves and coffee beans per day, the aroma production per day, and also the concentrate production per day. And as I said, you can log back on and view these at your leisure. In terms of dimensions, and this is really where it comes into its own, the IES-25 has a length of 16 meters, and I have to say that this particular design includes a spinning cone column, a decanter, a centrifuge, a filtration step, an evaporator, the tanks, and you can see the length 16 meters, the width 6 meters, the height 4 meters. And in fact, if you have a look at your local bus, the footprint of the IES-25 is not much different to the size of a bus in terms of height and in terms of length. In fact, we've left enough space for a forklift to go in between each of those modules, so that can be condensed even further. The IES-250 is a little bit larger, and at 30 meters in length, 11 meters wide, and again, that includes your tanks and includes space for the forklifts in between each of the modules. So really, we think the goal of what we set out to achieve with the IES of being able to efficiently, easily, flexibly, consistently produce ready-to-drink beverages of extremely high quality has been met. And our customers believe this also. And as you can see here, one of our Japanese customers is so confident of their product and the quality of their product that they're actually using a picture of the spinning cone column and saying that their special coffee machine is capturing the real taste of a cup of coffee and putting it into a bottle or can. So they're advertising using our technology. And we believe that the IES is producing high quality products all around the world, whether it be Europe, whether it be China, America, or Japan. And with that, I'd like to pass on to Phil, who would be talking more about the technical aspects of the IES system. Over to you, Phil.
Thank you, Leon, and hello everyone. So in this section, the benefits of the IES for the production of RTD tea and coffee products will be further discussed, and I'll make some reference to relevant process parameters. I'll also present some example performance criteria for the IES in terms of yields and concentrations when processing tea and coffee. Now, there's many reasons why customers choose the IES, and this list, I'd have to say, is by no means exhaustive, but contains many of the most common reasons. And being able to design and manufacture complete and bespoke IES systems that deliver a range of benefits is certainly very highly appreciated by our customers. The unique capability to continuously process slurry in the IES allows for high quality, authentic and natural products with fresh brew character to be produced. And there's also practical benefits, as Leon has referred to in recent slides, such as the relatively small footprint and height requirement for the system. The benefit of the unique slurry handling capability is particularly highlighted in this comparison between passing aroma recovered by processing only tea extract and the alternative of processing tea slurry. The vertical axis here lists a number of important aroma compounds identified in SCC condensate when processing black tea. The relative concentrations of each aroma compound found to be in the SCC condensate are now plotted on the horizontal axis. Now, the data shown in blue represents the concentrations in SCC condensate when tea extract is processed on the SCC. So in this case, the tea's been brewed in a batch vessel outside of the SCC and only the extract has been processed for aroma recovery. Whereas the data shown in red represents the concentrations of compounds in SCC condensate when the tea slurry has been processed on the SCC, as would be the case for the IES. And as you can see very clearly, the concentrations and therefore yields of important aroma compounds from slurry are significantly higher than they are from the extract. Obtaining high yields of these key compounds that in part define an important flavour characteristics underpins the real quality of the IES products and allows us to make these very individual aromas that in turn lead to product differentiation. So moving on to the topic of process parameters, Flavourtech has built up considerable process design knowledge for tea and coffee applications, and the list of process parameters presented here for discussion is again not exhaustive, but should provide some insight into how certain parameters impact on product specification and quality. So firstly, we'll take tea as an example and look at the raw material selection. Of course, the selection of the raw material is fundamental to the characteristics of the final product. Clearly, when it comes to tea, it's important to first recognize the differences between black tea, green tea, oolong, white, and so on, as the conditions used to process each type of tea will vary. Other factors I've indicated there, country of origin, growing conditions have an important impact on taste and aroma that the SCC can retain and capture. And for coffee, and similar to tea, the parameters affecting the choice of operating conditions on the IES are shown here. There are other differences here with coffee, the important one between Arabica and Robusta beans, for example, and of course the roasting conditions are additional factors. And the ability, again, to retain such differences from the selection that we make on, for the raw material in the finished RTD product is a real key benefit of the IES approach. So the next parameter that I'll discuss is slurry ratio. And on this slide, what I've indicated is the practical slurry ratio range used for tea and coffee through the IES. And as you can see, teas tend to be processed at slurry ratios of between 5 and 12%, whereas coffee may be between 10 and 20%. There are several factors that influence the selection of slurry ratios, such as particle size, shape, and wetting properties. And in any case, the first practical requirement is certainly to produce a slurry that can be pumped continuously without creating blockages in the system. So if we consider high limits for slurry ratio, as well as those fluid properties and avoiding blockages that I've already mentioned as being a critical factor, another one is extraction efficiency, and that may be reduced when less water is used. Generally, you're of course using less water and keeping concentrations high is desirable for a number of reasons, but too high a concentration will ultimately impede extraction efficiency of soluble solids. Now, when considering the limits at the low end of the slurry ratio, then the use of excessive water becomes the main issue. There could be a temptation, of course, to choose very low slurry ratios in order to maximize soluble solids extraction efficiency, but the higher volumes associated with very low slurry ratios may negatively impact on overall throughput. And when concentrations are being produced at perhaps 30 to 60% solids after the use of the Centritherm evaporator, then of course more water will need to be evaporated if low slurry ratios are used. And this would mean larger evaporators being required and higher product costs. Now, as previously mentioned, particle size is an important factor that determines the practical range for the slurry ratio. When considering the particle size applicable for tea slurry, it's perhaps useful to refer to the traditional size classification terminology used for tea. And this, I'm sure those of you in the industry will be quite familiar with some of these terms. The four main categories are defined as whole leaf, broken leaf, fannings, and dust. And it's fair to say that tea from all of these categories can be considered as raw materials for processing on the IES. Whole leaf and broken leaf will certainly require milling within the IES slurry preparation module in order to produce usable slurry. There's also, to some extent, a trade-off between raw material cost and quality to be considered. So whole leaf will be a more expensive starting material than dust, for example, but will certainly yield a better aroma quality. And in many cases, in fact, the compromise may be to choose a raw material from either broken leaf or the fannings category. So with the fannings category, as a general rule, slurry made with BOPF grade or equivalent can be expected to be processed without additional milling being necessary. BOPF grade, for those who don't know, is a common size for tea bag production and relates to dry tea particle size in the range of 1.2 to 1.7 millimeters. When it comes to considering coffee particle size, the most typical approach is to feed roasted whole beans to the mill within the slurry preparation system and to produce coffee particles in the range of 0.7 to 1 millimeter. And slurry made with coffee particles in this range is pumpable up to the 20% total solids and allows for optimization of soluble solids extraction, aroma recovery, extract quality and downstream clarification properties. So next we'll consider the SCC operating conditions in more detail. Now there's three principal SCC operating parameters that I'll define. The first is system temperature, and this we can define as the measured vapor temperature in the top of the column and is practically controlled by the pressure in the system. There is in fact two strip rates to define, the external strip rate and the internal strip rate. The internal strip rate is defined as the mass flow ratio of steam entering the bottom of the column of the SCC in relation to the slurry feed entering the top of the SCC. And the external strip rate is defined as the mass flow ratio of aroma condensate exiting the condensers on the SCC, again in relation to the slurry feed flow. The offset term is defined as the temperature difference between slurry feed entering the SCC and the system temperature. And the adjustment of these parameters can be used to change the profile and the concentration of aroma compounds recovered in the condensate. So as such, the selection of different combinations of these parameters allows for the recovery of aroma with very different profiles. And this in turn means that customers can differentiate their products in the marketplace and tailor specific types of aroma profile for certain products and the markets that are being targeted. So I'll now talk a little bit about a couple of those conditions and how they impact on the aroma quality. The first one is system temperature. This slide summarizes the typical operating range for the system temperature for tea and coffee when processing on the SCC. For coffee, the aroma compounds are largely generated in the roasting process at high temperature, and there's generally little reason to consider system temperatures below 100 degrees, as these compounds are generally not considered to be particularly heat sensitive. So an operating range between 100 and 120 degrees Celsius is typical. Generally with fresh brewed aroma compounds from black tea, they're generated when the tea is contacted with water close to temperatures of 100 degrees Celsius. In fact, as would be the case when you're brewing a cup of tea. This results in authentic fresh brew black tea aroma compounds being generated within the SCC and therefore recovered in the aroma condensate. In contrast, as you can see, when processing green tea, for example, it's found that varying the system temperature produces different flavor profiles that are appreciated in different products targeted at different regional markets. So, for example, seaweed character in green tea that's very often appreciated in Asian markets such as China and Japan will be more prevalent at lower SCC operating temperatures. In contrast, hay, grassy, or as we might call them, green characters will generally dominate the aroma profile when the SCC operating temperature is higher. So now moving on to strip rates. As we can see here, the strip rates used for tea versus coffee overlap to a large extent, but the extent of the range in each case is quite different. So in tea, most of the important aroma compounds are relatively volatile and can be recovered using low strip rates in the range of 1.5 to 4%. In comparison, the roasted coffee aroma contains a very large number of aroma compounds across a very wide range of volatility. And this means that depending on the character of the aroma desired, higher strip rates may be applicable. So the range of strip rate for coffee might extend from 2% right up to 8%. So taking coffee as an example, lower strip rates will generally lead to coffee aroma dominated by green and lighter woody characters. As we increase the strip rate, we're going to pick up more of the middle notes, perhaps related to roasted character. They will start to emerge. And then if we increase even further, we're going to add to that heavier compounds, perhaps imparting darker roast or even tar-like characters. And in any case, the various SCC parameters interact, so identifying the combination of conditions that give the desired overall profile is a really important part of the process optimization, and indeed presents customers with huge opportunities to create this wide range of differentiated products. So now we'll move a little bit further down the process after the SCC and consider the selection of clarification modules in the context of product specification. So the first task to perform after the SCC is the removal of bulk spent tea leaf or coffee grounds. And the most efficient way to achieve this is by passing the slurry through a horizontal decanter centrifuge, although a press may be used as an alternative. The resulting extract is likely to then require at least some secondary clarification. Typically this may take the form of a high-speed distack centrifuge. In the case of tea processing, the temperature used for this step is particularly important in order to achieve sufficient decreaming of tea, such that the required stability of the final product is achieved. When completely bright products are required, it may be necessary to apply a tertiary clarification step such as membrane filtration. For example, how the product is going to be packaged and consumed may influence the required clarity and turbidity. Often products in clear glass or plastic bottles need to be bright, completely bright, whereas if the product is to be consumed directly from an opaque packaging such as a can, then a completely bright product is not necessarily required. And the combination of these clarification processes is highly dependent on the raw material and upstream conditions, and of course, as mentioned, the final product specification. So the last process parameter I'll discuss is the final extract concentration. And the concentration target for the extract at the end of the IES process is highly dependent on the specific product and how the extract is to be used to produce that product. Storage and transportation conditions for the extract concentrate as well as the final product recipe will have a significant impact on what concentration level is appropriate. So as indicated, the typical range for tea and coffee concentrates may cover 30 to 50%, but could also extend to 60%. If the RTD product is to be bottled and canned on the same site, and this is something Leon mentioned in his discussion, then it may be possible to eliminate the need to concentrate extract after clarification. And so extract leaving the IES system may be as low as 2 to 3% solids in such examples with no extra concentration being required. And as has been mentioned, the the concentration of extract is achieved by the application of the Centritherm evaporator in order to maintain the very high quality of the extract in the process. And the Centritherm offers really great flexibility in terms of being able to produce extracts and concentrates or extracts at different concentrations for different product requirements. So that range, the same machine can quite happily produce a concentrate at 30% or a concentrate at 50%. It's just a question of some changes in the operating parameters. So in summary, we can conclude that careful consideration and understanding of the numerous process parameters in relation to the IS is critical to ensuring that the final product quality and specifications as defined by aroma, taste, balance, concentration and clarity is achieved. So the final part of this section of the presentation will be used to recap on the process overview and present some indicative extraction efficiency and yield data when processing tea and coffee using the IES. As previously discussed, a simplified flow diagram for the IES when applied for the production of RTD beverages can be represented by 4 modules: slurry preparation, extraction of aroma and soluble solids, clarification and concentration. While the achievable yield in such a process is high, the yield will be limited by the soluble solids that remain with the wet spent solids leaving the process at the clarification step. When it's important to achieve even high yield, an additional washing stage can be considered. There are several ways that such a washing stage can be designed into the process. In this example on the slide, a counter-current washing stage is illustrated, whereby the main freshwater addition to the process is made when washing the solids from the primary clarification step. A weak extract is produced from this additional washing stage and is then used to make up fresh slurry with raw material entering the process. Now, the advantage of such a counter-current process is that while the yield is increased, the concentration of solids in the extract prior to evaporation is also increased. So typical extract and yield data from a real example is shown here for black tea. In this example, the tea material was measured to contain 30% extractable solids, and the extraction efficiency using the standard IES was measured to be 85%, giving a yield of 25.5 kilograms of soluble solids per 100 kilos of raw material tea leaf. The resulting extract contained 3.1% soluble solids prior to concentration. And what you can see is by adding a counter-current washing stage in the right-hand column, this increases the extraction efficiency to 97% and the corresponding yield to 28.8 kilos of soluble solids per 100 kilos of tea leaf produced. The solids concentration in the tea extract prior to concentration also increases from 3.6% to 3.6% when using the counter-current washing process. Similarly, extraction efficiency and resulting yield for coffee is summarized here for both standard IES with the counter-current washing stage. And in this case, the measured extractable solids from the coffee was 28% when extracted at 100 degrees Celsius. When counter-current washing is employed, the extraction efficiency increases from 67% to 85%, and the corresponding yield increases from 18.7 to 23.4 kilos of soluble solids per 100 kilos of roasted beans. Now, although not referred to specifically in the presentation so far, the rotating disc column, or RDC, is a further technology developed by Flavourtech that can be employed in tea and coffee processing. This was originally designed for continuous high temperature conversion of non-soluble solids to soluble solids in powdered or instant coffee products. The RDC can be used, though, as an intermediate temperatures of perhaps 140 to 160 degrees Celsius to increase the soluble solids yield from roasted coffee beans for RTD applications where yield is a particular focus for the customer. Finally, for this section, we can conclude that the IES technology allows customers to produce products that are truly differentiated in the market. Due to the flexibility of the IES configuration, a range of finished product specifications is possible using the same IES process line. And by meeting the requirements of different markets with quality products, Flavourtech's IES is meeting customers and consumer needs. I'll now hand back to Con Grylakis, the CEO of Flavourtech, who will conclude this webinar by describing how Flavourtech can assist in improving your business.
So at this point, you've had a lot of information about our company, Flavourtech, about the IES system, and how changing or adjusting the operating conditions of the IES can change the type of products that you make, and the conditions of the products themselves can lend themselves to different markets and different flavor profiles. And what I'd like to do now is just wrap it all up by saying how can Flavourtech actually help you by using our technology to improve your business? Well, the first thing I'll say is that we have a very, very highly skilled team of chemical engineers, process engineers, and process engineers that actually know how this whole coffee and tea business works and can sit down with you and optimize your current process. In some cases, it means adjusting certain elements of it, or in some cases, we can design a brand new process utilizing some of our equipment or other equipment that's available in the marketplace. So certainly we can work with you to go through how to improve your business in that way. And then what we can also do is actually model the impact of our suggestions or our solutions on your business itself. We have a number of sales tools that we use and financial tools that can say that this investment would result in that return. We take into account all of the additional costs that you may have, plus all of the additional revenues or benefits or cost savings, whether it's energy or raw product and so on, labor, all of these things we take into consideration, and then we can show you what your payback would be on any of our systems should you go down our path. So we're able to model both the qualitative and the quantitative impact of our solutions on your business. And I think there's been examples provided already that you've seen today as to how we've done that with customers. The one example that stands out is this large Japanese company that has now bought its second IES and has enjoyed incredible market share from not even being in the top 5 8 years ago to being equal #1 today. The other thing that I'd like to point out is that in addition to installing and commissioning our plants or our systems into your factory, it doesn't just stand there. In fact, we see that as a start. What we'd like to do then is service and support you in a way that maintains that equipment working at an optimal level for many years to come. And to that end, we have a number of service and support packages that we call our Total Care Plan that can make sure we can support you either on-site or remotely through IT systems to make sure that your system's operating at optimally at all times. And I guess it's something that we say we do, and it's something we're proud of, but it's not just us saying that. It's actually something that's been recognized by independent bodies in Australia. In the last 6 months, we've been recipients of 2 awards. The New South Wales Business Chamber has recognized Flavourtech as a regional winner for excellence in export, and we received that prize late last year, which we're very proud of. And then in addition to that, shortly afterwards, in October of last year, we were also the New South Wales or state winners of the Export or Innovation in Export Award from the Export Council of Australia. And both of these awards, I guess, are very important for us because it gives us confidence that we can actually meet the needs of our customers, and it gives you confidence to know that if you deal with Flavourtech, we'll meet your needs both today and for the long term. Thank you very much for listening to our webinar. Of course, if you have any questions, you can contact either myself, Leon, or Phil, either directly through our email or at our website, and we'll be more than pleased to follow up with you and talk further about your business and how we can help you. Thank you very much.